Welcome to SharkNet's bi-weekly webinar series. Today I'm going to cover Git, and I'm calling it Git Part 2. Now, I've previously covered the introduction to Git, which is recorded on our YouTube channel. And today we're mostly going to focus on how to undo some changes, some settings that are important to everyone in your everyday usage of Git. And we're going to dive a little bit into what's going on behind the scenes so that maybe you can understand Git just a little bit better. So the first thing we're going to cover is the config files. So the git config command allows you to easily manipulate Git's config files. There are three main levels for the Git configuration file: the local, the global, and the system. By default, Git will write to the local level if no configuration option is passed. The local level configuration is applied to your repository that it's set in. So when you're in a repository and you make a change to your configuration file, it will go, if you use local, which is the default, it will apply only to that repository. Now, if you want to do for your all of your repositories, the global level configuration is user specific. This means that the set of values are applied to all repositories belonging to that user. So these global configuration files are stored in a file in your home directory called .gitconfig, while your local ones are stored in your repository under the .git directory called config. And then there is a third level, the system level, which is applied across the entire machine. And this affects the repositories for all users on the system. Of course, the system level configuration requires admin access, so you can set them on your home computer, but not necessarily on the cluster. To add a file with git config, use the git commands, the git program. The command is config, and then you include the level that you want: global, local, or system. Here are a few examples of some common ones you'll have to set. The user.email, so this is the key value that you're setting, the key that you're setting, and this is the value that you're setting. Now the user.email and the user.name are required for when you push to a remote repository, and Git will prompt you to set those when you do so. Another common setting is the editor. So core.editor, if you want Emacs, or you can set core.editor to Vim, or you can look up and see which one you want. The reason I've got these both in here is to point out that you can have a local setting which will override the global or the system level settings. Because they all reside in different files, this allows you to have multiple settings. If you want to remove a value from your config, you use --unset. So you use git config, you specify the level that it exists at because they can be set in multiple levels, the --unset, and then you just include the key value. And of course, again, if you are doing it in if you're doing it in the system level, you'll have to have sudo or administration access in order to unset your config file. So here, if you want to list the values in your config file, you've got git config --list, and that'll show you your key value pairs. If you include the --show origin, it'll also show you the source of the file. So you'll see here, etc.gitconfig, I've set the editor to Vim. That is system level. Here, these are set at global levels. These are all user level settings for your email, your name, and some aliases. Now, aliases are probably the most important part of a configuration. What an alias is in Git is it allows you to do a shorter command. So if you do git config global alias.co checkout, now whenever you go git.co, it'll do a git.checkout for you. And that's a very common one. One that I like to use, which you'll see in some of the presentations later on, is the LG, and that means log. So git log is a very verbose command, and you'll often want to shorten it just for quick information. So --all, one line, and only the top 20 lines. And I just put that to LG. That way I can use log or LG for just the quick. We're now going to cover gitignore. Now, the role of gitignore, it's a file that resides in your Git repository that tells your repository what things to ignore, what things not to look at. So when you add things to your staging index, if a pattern is matched in the gitignore file, it won't get added to your index. So this is an example of a gitignore file. The .gitignore file resides in your project's root directory, and there's no explicit gitignore command like there was with git config. You will need to edit this file manually. So each one of these is a pattern. They're called glob patterns, which not quite like regex. They will tell you exactly how you use wildcards to specify which files will get ignored. Now note that these files won't get added to your staging index, and Git will ignore all modifications made to them. However, if a file is already in your staging index, then modifying your gitignore after the fact won't cause it to be ignored. So it only ignores files when they get added. So it prevents files from being added to your staging index. So some examples of gitignore commands. So if you have just a line in your gitignore file, for example, settings.cfg, it'll ignore the file in your root directory called settings.cfg. It'll also ignore any file in any subdirectory called settings.cfg. So foo.cfg will also get ignored. And so any nested subdirectory with a file that matches that name will get ignored. Take a note, however, settings.cfg could also be a directory. Although it's a poorly named directory, it could be one. And if you have one with that name, then all files within that directory will also be ignored. Now, more typically with a directory, you're going to want to specify it explicitly, and the slash is used as a directory separator. Trailing slashes after a string or after a word match directories only, not files. This, for example, will match the log directory, and all files within the log directory will be ignored. So if you have a log directory with january.txt and you have this rule, that will not be added when you use the git add command. However, if you have a file called log, it will be added because this applies only to directories. Note that this still applies to nested directories. So if you have a /bar/log, then that directory, that subdirectory underneath bar, will have all its files ignored as well. You'll often want to put a root directory. So if you specify, if you have a preceding slash to your string, it means root directory only. So the file in this example, output.txt, in your root directory, output.txt will be ignored. However, if you have a subdirectory with output.txt in it, it won't be ignored. So only the root directory will be ignored with a preceding slash. And this allows you to really be explicit on which directories do and don't get ignored. Absolute path. So what the root directory, the preceding slash, is really doing is just saying from root, follow this path. So you can also include the absolute path of a file or a directory. So that means in this case, config/logs is the absolute path, and all files in your root directory under config.logs will get ignored. However, because this chain of directories is explicit or absolute, if you have a foo directory and underneath that foo directory is a further config directory, and then your logs directory, that won't get ignored. So that's this very explicit path of config.log. If you're familiar with the bash command line system, it's almost the exact same thing, the same patterns. So the real power with the git ignored comes in what they call the globs, which is a wildcard system for specifying file names. The first one, and the most common one you'll see, is the asterisk or the star. And an asterisk matches anything except a slash. So that means we're going to match, we're not going to match into directories here. So in star.log, this will ignore all files that end with .log in all directories. So today.log will get ignored because it ends in .log, same as january.log. The thing that precedes the .log is a wildcard part. Note that bar.log in a nested directory gets ignored. And of course, because directories can have dots in them as well, if you have a directory called my.log, everything within that will get ignored. An important caveat to the wildcard, the asterisk wildcard, is that there can be an empty string. So it will also ignore the .log file. It doesn't have to have something in that asterisk, so it's 0 or more characters. You can also have the wildcard within the string. It doesn't have to be at the beginning. So in this case, this will ignore all files and directories that start with out and end with .text. So out1 starts with out, ends with .text, it'll get ignored. Out_log, same thing, starts and ends with the specified wildcard. Out.text will also get ignored because the wildcard itself can be empty. However, in this last case, file_out_log.text won't get ignored. And the reason for that is we have specified it must start with out, not just contain it. So in this case, it doesn't actually start with out. It contains the out_log.text, which looks very similar, but because of the preceding file, it's not going to match. The question mark wildcard. So this matches any single character except for the slash character, which is your directory descriptor. And the important difference between the question mark wildcard and the asterisk wildcard is that it must contain a letter, whereas the asterisk could be empty. The question mark must have something, and it's a single character. So in this case, sequence 1, because it's a single character, that will get ignored. It matches. Sequence A matches. Sequence 11 doesn't match. So what happens is because there's 2 characters there, it's not going to match. And sequence.text also won't match because it actually requires a character. Similar to the character is a range notation. So in here we have log and inside square brackets 0 through 9. And that means we can accept any character 0 through 9 and it must exist. So blanks won't get matched. So it starts with log, any character 0 through 9 ends with .text. So log 0 text, it's matched. Log 5 .text, it's matched. Log 15 does not because it's any single character within that range. And of course, log.text doesn't match because it requires one of the characters in that range. So a custom range notation is similar to the range notation, except that this is more of a set notation. It will match any of the characters within there. So if it doesn't have a dash, 0 through 9 dash, you can also have an A through A-Z. If you don't have that dash in there, it's going to match one of the characters within the square brackets. So starting with foo, A.text matches, foo B.text matches. Of course, 4 is not in there, so it's not going to match. And the same rule as the other range notation, you must have only one of the matching. So AB would have 2, and it only requires or only accepts 1, so that won't match. And of course, you can also mix notations. So you can have star 0 through 9, which is just wildcard notations .log. That means that any string or any series of characters followed by a number and .log will get ignored. Bar 0 matches that criteria. File1.log matches that criteria. Now file11.log, well, it looks like at first it shouldn't match because file 1 matches the star character and the 1 matches the 0 through 9 range character. This will get ignored. Bar.log doesn't match because what this is saying is you must have a number before the dot character in order to match and get ignored. And of course, that doesn't also apply to bar 0a.log because we have the correct bar 0 matching, but there's something between the number and the dot. And this is just to show that you can mix the range note, you can mix the notations all you want. You have multiple asterisks, you can have question marks and asterisks, etc. Now the not location. So this is the negation. The exclamation mark will negate a pattern that has been defined by a previous rule. So in this case, we've defined star.log, but we're going to say we will ignore everything with ending in a .log, but we're not going to ignore persistent.log. We want that file to be tracked. So foo.log will get ignored because of this. The star.log, bar.log will get ignored because of the rule. But of course, persistent.log will not get ignored because we've used the negation operator on it. An important distinction with the negation operator is that when gitignore reads a gitignore, or sorry, when git reads a gitignore file, it does so in order. It goes from top to bottom. And the negation will only negate rules that have already shown up. So if you want to negate all log files, star.log, but you don't want to do persistent.log, if that shows up first, it's still going to get ignored because of the rule came after the negation. The negation has to come after the rule in which it's negating. So the star notation and a leading double asterisk matches all directories. And this is a special case and can get a little confusing at times because the asterisk does most of this for you. But it means any series of nested directories followed by, so in this case, any series of nested directories from the root directory followed by foo and bar. So the foo bar bar file inside a foo directory. So the bar file inside a foo directory gets ignored. Deep or any series of subdirectories followed by foo with bar, that file will get ignored into it. And what we're saying is there's not allowed to be anything between the sub and the foo and bar. And the reason I include this is mostly to be pedantic, is that you'll see these in some files, but in most cases you can get your roles more clearly defined with a single asterisk. So git check ignore. Once you've set up your git file and you've set up your your gitignore file, you want to be able to see what's going on. Now, one way, of course, is looking at git status, and git status will show you what files are going to get modified or what files will get included. However, git check ignore will tell you explicitly which files get ignored, and the format is git with check ignore minus v is verbose, and then a list of file names that you want to check. So in this case, we will git check ignore minus v file.log, and we're going to include a single file name. And it tells you, because of the -v, the verbose, it tells you which file it exists in. We only talked about one gitignore file, but you can have multiples in any directory. And the file that gets ignored, so file.log gets ignored. If you want to git check ignore your entire directory, your entire repository, use this */* means nested all directories. And because that doesn't include the root directory, you include star. So that's two different file names. And this is just showing you that on bash or on your command line that these globs also apply. And that's where they come from. And the output here, it goes 3 lines. So in our particular example, there was a foo subdirectory that got ignored by star.log. File.log got ignored, record.log got ignored, and file.log in the root directory also got ignored. And you can see that you can find the rule in the .ignore directory on the first line. We are now going to move on to stash. So what git stash does is it I seem to have lost my laser pointer. Oh, there we go. What git stash does, it temporarily shelves or stashes changes you've made to your working copy so you can work on something else. And it's usually used as some sort of hot fix repair. Now, after you've gone and worked on something else, you can come back and reapply the previous changes later on. Stashing is handy if you need to quickly switch a context and work on something else, but you're midway through another code change and aren't ready to commit it. So what you're going to do is it's going to reserve your working directory changes so that you can recover them. We're going to do a little example here in a pre-recorded terminal session I've done. and that'll show you how stash works. We're going to start with the repository in an unchanged state. And we're going to modify the hello world file. So we can see this modification here. It's changed. We can use git status to see that hello world is part of the staging index and has been modified, but no commit has been made yet. So we're now going to stash this change and take a look at the index now, which is again a clean working tree. Git stash list shows us how many stashes we've made. At this point, it's only one. Furthermore, looking at the hello world.txt file, we can see that our change is no longer there. So now we're going to modify another file called datetime.log, and you'll see that there's a new line in there. We'll add that modified file to the staging index and commit it to the repository. We'll now pop the changes back into the working directory, and we can see that the hello world.txt file is again modified. Taking a look inside it, our modification's back, and the datetime.log file hasn't been changed. Taking a look at the git log, we can see where we are after the changes. So the important takeaway from that is git stash will push your current working repository, so your current working directory, into just a separate repository, and you can make changes to other files. And then you use git stash pop to take them out of your saved stashes. It's also important to note that you can do multiple stashes if you like, and that's why we use the git stash list to see them. Although be careful, because the more stashes you get, the more confusing things get. And then when you pull them back out, they could have conflicts with each other. So it's best just to keep your stashes to 1 or 2 and do your hotfix. Otherwise, you should probably be better off committing and then pulling out a branch or doing a branch. We're now going to talk about the internal state of Git. And this is a bit of a change of pace in what we're doing, or a change of subject. Whereas before we were talking about specific commands, we're just going to take a little bit of a peek under the hood of Git. And my goal here is to show you that Git is really nothing special. But if you, and it's just a subdirectory that exists within your repository. And it's just all your different rules, or sorry, all of your different pointers and all of your files are kept in there. And if you can understand this and you take a bit of the mystery away from Git, it's a lot easier to understand what the other commands are doing. So first, we're just going to cover a bit of review from the previous presentation in your git add commit cycle. So in this command, so we're going to start, we have git init, git reset test. That's just starting an empty Git repository, and we'll call into that. And so we modify a file here. We've just added a line to my file, and you add that. So git add my file, what that's doing is it's adding it to the staging index. That's kind of it's a temporary holding. It's telling Git what we are currently tracking. And then git commit commits the staging index to the commit history, or your commit tree. And that's basically day one with Git, right? That you've all covered before. But let's take a little bit of a look inside of what's going on. So when you do, inside Git, inside your Git repository, if you go ls.git, you will see, you'll see the Git files, or the Git repository is saved in a subdirectory called ls.git. And then called Git. And then inside of that is Git objects. And when you add a file to the Git repository and go status, I'm going to pull up a terminal in a second and show you this. Just covering it first, sorry. You add a file, my file, and then you go git status, and then we'll ls file. So this is a new command here. And what this is doing is showing you your staged files. So ls files is list git files -s for staged. So I'm just going to switch my screen sharing here to a terminal. And we're going to do this manually instead of the pre-recorded version I had before. So hopefully everything goes smoothly. Let's share screen here. I can say so in the chat. Actually, I've lost my chat. If you can't see properly. So here we go. So I've got a repository called demo, and I'm just going to clone demo. So git clone demo into my demo clone, and that's just so I keep the original one. So here we are. We have a repository as it's going. We'll take a look at status, not status. Git status is more important. There we go. Git status. So nothing to commit, working tree clean. So what does that mean? That means nothing that we have in the root repository or in the repository has been modified. And what we're going to do is we'll go ls.git. So ls, sorry, we'll go ls minus al to show you everything. And you'll notice that there's a .git subdirectory there. And if we look at the .git subdirectory, there's a whole bunch of things in there. There's a couple of files, a couple of directories. What we're going to look at in particular is the objects directory. We're going to look at .git/objects. And there's a whole bunch of things here. 25, 4D, AC, these are all directories. And if we go tree.git/objects, tree, if you have Linux, you can just install it with apt-get. And you can see that there's files in here. And what these are is these are compressed files. These are the files from your working directory that have been saved in their different states. And every time you do a -add, so we're going to actually do a new directory here. New repo, sorry. So we'll call it a new repo and look at .git/objects. And it's empty, there's no objects there. So let's just do, let's just modify a file. So we'll echo hello world into hello world .text, right? It's there, so git status. Nothing going on now. It's an untracked file because we haven't told git to track it. Git add hello world.txt. It is now in the staging index. It is now a tracked file. So let's take a look at git status. This is your common one that everyone uses regularly, and it just tells you there's a new file. But what happened to the git subdirectory? Well, now there's a 3B. So we'll look in the tree, we'll look a little bit more details, and there's now a file there. And what that is that's the hello world.txt file that's being compressed and saved. But that's not the whole story yet. If we go git ls files -s for stage, it also shows us that, and it gives us some information on it. And that's just your file bits. That's the hash. You should be well familiar with the SHA hashes by now. A size, for some reason 0, and the name of the file. Now we're going to move on. And we're going to have a little bit more of a look at it. These commands are on the slides, as I read out a second ago. And we'll go back to them and we'll just rehash what I've done here. But we'll go through it first. So we get ls files. Looking into, we're going to cat. So this file here, so the 3b18e5 and so on. If you look in ls.git/objects, there's a 3b directory. And that's just the first 2 letters of your hash file. That's just the way Git divides things up to make things quick to look up. And of course, in there, in the 3b directory, is that file, the 3b18e5. And that's just where they are. It's just a file name, and we use an SHA hash to identify it. Of course, if we look at it, we should get gobbledygook because it's compressed, right? There's nothing in there of interest to us because it's a compressed file. Instead, we're going to use a command called git cat file. And cat file looks at the contents of an index by hash. So we look at our git status, oh, not git status, git ls-s. So we go git cat file, and there's three commands here. There's a -t for show object type. Now we don't have to put in the whole hash because that could be tedious. And 3b18 will give you this, and it says blob, and blob just means a compressed file. If you go -s, tell you the size of the file, it's 12 bytes, it's just hello world. And this is the interesting part, is the -p, and that uncompresses it. That uncompresses the file that we added with git add. Now the next step is going to be a commit, and we're going to see something happen here. So this is where we are. We have a new file that's now staged. It's in our index, but it's not in the repository tree. Git commit -m for message initial commit. There we go. We'll just take a look. Remember this fe68. So that is whenever you look at your log file, that is the head of the master branch, and that just tells you where to find it, and that's review. If we look inside the .git/objects file, you'll notice there are now three subdirectories starting with letters with hash values, and that's because git commit has now added things, and we're going to take a quick look at that. So we'll roll a tree with .git/objects, but easy to understand. So there's now three files here. There's our 3b18 file. We're familiar with that. That's our compressed hello world file. And there's two new ones of particular interest. Oops, sorry, git lg for log fe682bf 682bf. That matches the hash file for the head of our master branch or our commit. So let's take a look at that. We can use cat file, or git cat file -t to get the type of the fe68, and it's a commit. The type is a commit, so it's telling us that this contains information about a commit. We can look at the size, 168 bytes, not really relevant to us, but again, of particular interest, -p for contents. And here we go. There's a tree file, an author, your name. If you remember from the config earlier, we could set your name in your email, and that's where these get stashed. So whenever these get pushed, your name and your email is part of the commit history. But we have a tree, and this is the EAF7. And if we recall up here where we have a mystery file, we've got our hello world.txt compressed file, we've got our commit information, and we have this other file which we hadn't covered yet. And that is the EAF7 is a tree. And all a tree is a collection of files. You can think of it as a directory in Bash, but it's just what Git calls a directory. So we're going to take a quick look inside of that EAF7. Type first, EAF7 should be tree. Size, not too relevant when talking about trees, 42 bytes. But the contents, and what's important here is this is the blob file. This will all come around in a circle. This is from your status. Your staging index has been saved here. So basically, what we use for -add, when we go git add, it modifies your staging index by adding those files to it. That staging index is then saved as an object called a tree inside a commit. So that's on the video now, obviously. So you can go back and rehash that a bit. It sounds muddy, but it's a fairly simple concept, and it's just to show you that everything in Git is just a file. So I'm going to continue with these slides now. So we're just going to switch back. We're going to change the sharing. I'll stop the share, and we'll switch back to my slides. And that would be you. There we go. And share sound is on for the videos. So you'll see here, I've included in the slides so you can look at them later on. If you want to just look at the slides, the commands that we used to do that. So to review, ls files shows you what's in the staging directory. Git/object just contains the files that, or the objects that are relevant to your Git repo. And then you can just look in the various subdirectories there. Of course, the first two letters are of the hash, and then the rest of the hash is a file name. Oh, next slide. So git cat file we also covered. So if you look at the help for the git cat file, git cat file -t s or p for show object type, show object size, and p stands for pretty print, in case you're wondering where they got that p from. Pretty print the object's contents, and then the hash, which of course you don't include the entire hash, the first 4 characters, or the first 4 characters that distinguish the file, right? And then this will show you what happened. If you're wondering and you want to see what the actual compression algorithm is that's used by Git, is a package called pigs that will unpack the file for you. That's not important. That's just here for interest's sake. The tree will give you the Git directory. So inside of that is the C8 directory with the rest of the hash, the file name. And then we did the commit and the tree. And of course, what's in the cat file, etc. So what this brings us to is the 3 trees. So now you've heard me talk about the commit history, or I often just call it the repository, the staging index, which is where things are waiting to go into the repository, and the working directory. So the working directory is the files that you have modified. It is simply the directory that bash sees, or the directory on your computer where you make the modifications. The staging index, so when you do git add, it's going to add a file to the staging index. It's a blob file, which means just a compressed file, and it will be located under the object C8 with their hash file. And that's what that's doing. That's adding it to your, so it's now saved, it's now compressed, and it's being copied to the subdirectory. When you do git commit, it's going to create 3 more objects, or sorry, it's going to create 2 more objects, and it's now considered to be part of your commit history. It creates your commit file, which points to a tree, which points to a blob. And it's important to point out here that a tree can have multiple blobs, and they can also have other trees. And it's just the way that we build up how we know that your repository, or how your repository looks. Quick look at the time. So we're revisiting checkout. Now, checkout is something that I covered in the previous presentation on a way of recovering files. And we're going to talk about how checkout works in context of the background or the plumbing of Git. So when you go checkout -- my file, to you, you're saying, I want to get my last revision, or what happened. But what's really happening is Git goes, okay, we're going to look into your commit history. We are going to uncompress the file, and we are going to overwrite your working directory. So it's the previous version. So you lose the work you've done on the modification. So checkout is a command that means unpack or uncompress a commit history file and put it into your working directory. Now that sounds dangerous. So a better way of doing this, particularly if you're working on a repository by yourself, is commit your changes before checking out. So in this case, we'll commit -add means add the files in the staging that are already staged. Put in an M for message broken file. So you'll see that we have a broken file. Commit, that's the message. Then we're going to check out the FA127, the previous commit, and the file name of interest. And then we will recommit these as the proper file. And what this does is we now have a save of our modifications and then a save of the fix. And that way, if you ever choose to undo your undo, you can. Pushing forward, we're going to have a quick little look at Revert. Now, we're only going to touch on this subject because Revert can get quite complex as you look into it. However, if you use it on just the head node, it actually does what we just talked about automatically. So we do a log, we've got a commit here. We're going to call this revert from here. We're going to revert from here. We've added a third and go git revert head. So what this means is we're pointing at the head node of our default directory, which is the master directory or the top of the directory. This reverts commit B7, that's an automatic message. When we look at log again, so what happens is git revert will check out, we'll create a new, like we did before, git revert will commit the changes you've made to your working directory before checking out the files from your repository. And this saves it in case you make a mistake. I'm going to skip over the non-head node. So when you do a non-head node, it can get messy in that you have to do a merge. And that means you've done some sort of 2 or 3 back from the head of your default directory. And just what I want to take away from this slide is if you ever see the ~3, that's what's going on. And the -X there means I'm going to merge with what I pull out. That just gives you an idea to look further. However, I want to push on and talk about git reset, because git reset is what you're going to see almost if you're going to look on for help online on how to fix something in your Git repository. You're going to see git reset a lot. And git reset has mixed blessings. It's very powerful. It's also very dangerous. So it's good to understand how it works. So git reset is a command in Git, same as before. The command is called reset. What happens is you target a node, typically the head, but you can target any SHA hash. And then it's got 3 settings: hard, mixed, and soft. And we'll talk about those 3 now with a quick example for each. So git reset hard affects all 3 trees of your Git repository. It affects your working directory, it affects your staging index, and it affects your repo. Any new files that are staged when you do this will be deleted. Any tracked files, that's files that you have used add-on at some point, and that are altered will be changed to match the specific commit. Only new untracked files remain untouched. So this is, while this is the most frequently used flavor of reset, this is the most direct and dangerous flavor of reset. The hard option updates the commit history reference pointers to this specific commit. So it basically erases your working directory and replaces it with the head of your branch or the head of your directory. The staging index and working directories are changed to match the specific commit. Any previous pending changes to the staging index and the working directory get reset. This means that any pending work in the staging index and any pending work in the working directory that you haven't saved are lost, and they're lost permanently. In essence, it changes the state of your repository to match that specific commit. We will now do a demonstration on my pre-recorded terminal.
Starting with an empty repository, we're going to add 2 new files and modify one of them. The first file is going to be unstaged, and we'll call it unstaged. The second one will be staged, and we'll call that one stage.txt. And thirdly, we'll modify the hello world.txt file. We use git add to put the stage.txt file into the staging index. You can see from the status that we have a new file called stage.txt, a modified file called hello world.txt, and an untracked file called unstaged.txt. Looking at the git log, we'll see that the head is currently at the added license file, and we're going to reset to the head, which is the default. The head is still at the same check-in, and if we take a look at status, the only file remaining is unstaged.txt. Stage.txt has been removed. We're also going to take a look at inside hello world.txt, where you'll see that the modified line has been removed. It's been reverted to its previous state.
The takeaway from that video is if you have completely borked your working directory, you can always use git reset hard to make it match the head of your repository. But be careful, because any changes you made in your working directory are now gone. The default reset, so that we had to specify hard. Git reset head mixed is the default, and it will any new files that are staged will become unstaged, so it cleans up your staged index. If you have modified files in your working directory, they will remain modified. So this is a much cleaner way of just kind of undoing a bunch of commits or undoing a bunch of adds, right? It resets the staging index, which is the tracking of which version of the files you want in this commit.
Again, starting with the demo repository, we're going to add 2 files and modify the third. The file that we'll stage will be called stage.txt. The file that we won't stage will be called unstaged.txt. And we'll modify hello world.txt. We now add stage.txt to the staging index and check the status. We can see that stage.txt is new, hello world.txt has been modified, and unstaged.txt is still untracked. We will now perform a reset, which by default operates on the head node of the current branch. The output lets us know that there are unstaged changes in the hello world file. Using git status, we can see that stage.txt, which was previously added to the staging index, is no longer tracked. Also, if we have a look inside the hello world file, we can see that the line that we added is still there.
So we can see that this is a much safer way to undo your changes, because it doesn't actually change your working directory. What it does is it stops your tracking that you have done, and it lets you continue to do some more work. The last option is git reset soft, and git reset soft makes the least changes to your working directory and your staging index. What we've done here is you'll see that typically when you use it, oops, go back. Typically when you use it, you see the ~1. And what you git reset soft on the head node doesn't actually do anything, because it leaves the working directory and the staging index untouched. What it's best to do is, if you have a bunch of commits that you maybe have made a bit of a mess in your commit history and you want to keep the same changes, but you want to commit them in a different manner, then you'll use the reset soft. So it changes your history without really changing your files.
We're starting the project again by making the staged.txt file the unstaged.txt file and modifying the hello world.txt files. You can see in the status that the hello world is modified and the other 2 files haven't been added. So we add the staged.txt file and track the hello world.txt file, and we can see that those changes are now staged for committed. The difference here is we are actually going to commit the changes to show you how they get undone with the soft reset. You can see we have a new head node on the master, and the unstaged.txt file is still there and untracked. We now reset soft, targeting the previous node, and we can see that we are now at the ACE 7 node for the head. If we look at the status, the hello world.txt and stage.txt files are still modified and staged, and the unstaged.txt file still exists. Furthermore, if we look at the hello world.txt file, we'll notice that all changes are still there.
So to repeat, all that does is undo the commit without actually undoing the changes. And this is just a way, if you want to, typically if you commit a bunch of files together and you meant to commit them separately, this is a good way to reverse that and then commit them one step at a time to make a very clear commit history. Thank you.